All right, welcome back, ladies and gentlemen. Today, we are going to be continuing our discussion of right triangles, but we're going to be looking at right triangles in a little bit of a different way, finally talking about simplifying perfect squares, and square roots, something we've been talking about how we're going to review with you for a long time. So I think we're going to start there with simplifying square roots. Okay, so the first thing we want to talk about is perfect squares. So a perfect square is a square root in which there is no decimal. Okay, it's basically a number times itself is that number under the perfect square. So our perfect squares go as followed. Okay, the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. And the square root of 64 is 8. The square root of 81 is 9. The square root of 100 is 10. The square root of 121 is 11. The square root of 144 is 12. The square root of 169 is 13. The square root of 196 is 14. The square root of 225 is 15. I'm going to stop there. There are some other perfect squares that sometimes show up. For example, the square root of 625 is 25. There are some other ones out there, but that's really where I think we need to stop for our discussion. So these are all numbers that we get no decimal on the calculator with. But what about something like, let's say, the square root of 50? There we get 7.0710678119, and that's great, but is it really great? We really want something a little bit better, right? We want something that allows us to not have a decimal. And so to do this, we use simplifying square roots. So let's start with this problem here. Might as well start with radical 50. So starting with radical 50, what we're going to do here, okay, and I'm going to show you along with the calculator, we're going to divide 50 by perfect square numbers less than 50. So we have to start with the biggest number less than 50. So the biggest number on this list less than 50 is 49. So we're going to start by dividing 50 by 49. And it's as quick as just plugging into your calculator, and we're looking for the highest number we can get such that we don't get a decimal. And you have to start in this order. Okay, so 50 divided by 49, we get a decimal. It doesn't work, we go to the next one. So 50 divided by 36. It doesn't work, we go to the next one. 50 divided by 25. It works, excellent. So the numbers that we're going to be using are 25 and 2, with 25 being the perfect square. So the next line that you're going to get is going to be radical 25, radical 2. Basically, you're breaking the 50 up into radical 25 and radical 2. And this works because 25 times 2 is 50. Properties of radicals allow us to do this. Now, the final step here to simplifying this radical is you just simplify the radical that is a perfect square, meaning that radical 25 and radical 2, right, your final answer is going to be 5 radical 2 because the square root of 25 is 5. And it's that simple. So when we ask you to do something like, for example, radical 72, and we ask you to simplify that, let's try and simplify it. So 72, the smallest number, is 64. That's just less than it. So we're going to do 72 divided by 64. Doesn't work. There's a decimal. So then we'll try 72 divided by 49. Doesn't work. There's a decimal. So then we'll try 72 divided by 36. It works. So we've got 36 and 2. as our radicals. So what we're going to do is, again, the perfect square comes first. So radical 36, radical 2, and we're going to then simplify that radical 36 to be our 6 radical 2. And that's it. That's how we simplify these radical equations. Okay, so let's do one more just so that we can say we've done a couple. Radical 27. So 27, I'm going to start by dividing by 25. Now, trust me here, you may think that, like, well, 25 is never going to work, the two numbers are too close. Just, it takes 2 seconds to plug into the calculator, plug it in, get the number, go from there. 27 divided by 16. Okay, we get our answer, 27 divided by 9. There, I get something that's not a perfect square. So I'm dealing with 9 and 3. So again, the perfect square comes first. So radical 9, radical 3. The square root of 9 is the number 3. So I'll get 3 radical 3. Now, just to show you how this works, just so you can check your answers. Okay, so let's say what is radical 27? Radical 27 is 5.19615242227. Some number in the calculator. Remember, it keeps going. My calculator only gives me a certain number of digits. Let's check the answer we got. 3 radical 3. Would you look at that? We got the exact same decimal. So that allows us to just prove that we got an equivalent answer. Okay, so that was our review on simplifying perfect squares, simplifying radicals and square roots. Okay, so with that being said, let's now take a look at what we can do next. And what I mean by that is, I said we were going to continue talking about right triangles. We're all familiar with the Pythagorean theorem. Okay, so we've got a squared plus b squared equals c squared. Okay, a squared plus b squared equals c squared. And a, b, and c are just sides of a right triangle. And we know this Pythagorean theorem allows us to, find the missing side. So this is going to be a little bit different than what we were doing with SOHCAHTOA, where we were using right triangle trigonometry to find the missing side. Here we know 2 of the 3 sides, and we're going to use Pythagorean theorem to find the missing side. So what we're going to be doing here is we're going to be looking at a problem, for example, like 3 and 4, okay, and we're going to be missing the hypotenuse. So that would allow us to do 3 squared plus 4 squared equals x squared. I'm jumping ahead of myself here. Look at that. I'm giving you the answer. So x squared. So 3 squared is 9 plus 4 squared is 16 equals x squared. 9 plus 16 is 25. And I can take the square root and I'm going to get 5 equals x. And that's my answer, right? But now the question becomes, well, what happens when I have something that doesn't work, right? Like, what happens when I have something that just simply doesn't get me a perfect square like 25, right? What happens when my right triangle isn't a perfect square? So let's see. All right, so ladies and gentlemen, this is a delta math question that we could be presented with. Okay, we've got a right triangle here with sides 11, hypotenuse 61, and we don't know the bottom part of that triangle. And what we're going to be asked here is we're going to be asked to find that third side in simplest radical form. So let's go ahead, let's draw this, and let's see if we can solve. Okay, so we have this blank triangle here, and we've got an 11, we've got a 61, and I'm going to put an x there. We just don't know what that side is. So remember, again, just like last lesson, I recommend labeling the hypotenuse. Now, you can't label the opposite and the adjacent here because we don't have an angle labeled, but we don't need an angle. This is Pythagorean theorem. So we're going to deal with 11 squared plus x squared is equal to 61 squared. Okay, so again, you have a calculator if you need one. Okay, we've got 121 plus x squared equals, now 61 squared you definitely probably need to plug into your calculator, 3721. Okay, we're going to subtract 121. And we get x squared equals 3721 minus 121. and we get 3600. Now, great. The first thing you gotta do, ladies and gentlemen, is you gotta check to see if it's a perfect square. Try it. If it doesn't work, it doesn't work. But if it works, the answer is just 60. Okay, so the answer is 60, and I can go to another question. So my answer here doesn't even require a radical. It worked out. So yes, I want to submit it. Let's go to a new problem. So this time, I've got 1 and I've got a radical 53. So let's try a new question. Okay, so I've got my right triangle. I've got a 1 and I've got a radical 53. Well, let's make that a little neater. And I'm looking for the hypotenuse. So it's going to be 1 squared plus radical 53 squared is equal to x squared. Okay, so with this here, the 1 squared, right? The 1 squared is just 1. The radical 53 squared, the squared and the radical cancel out, and I just get 53, and that's equal to x squared. So I get 54 is equal to x squared. Try it. See if the square root of 54 works. If it does, great. If it doesn't, okay, we'll move on. So I get my, decimal, and that doesn't work. So now what I need to do is remember my list up at the top, and I need to try numbers less than 54 that are perfect squares. So the first one that I'm going to try is 54 divided by 49. Doesn't work. Okay, so we're going to go to 54 divided by 36. Looks like it could work, but it's still got a decimal, so it doesn't work. So 54 divided by 27, and that works. So we're going to be taking the square root of both sides. We're going to get the square root of 54 is equal to x, but now we've got to put it in simplest radical form like the directions say. So we've got a 27 and we've got a 2. Now wait a minute, 27 is not a perfect square. Hopefully someone checks that. So we can't even count that one. We tried 25, that doesn't work. Okay, so we'll try 16. So 54 divided by 16, that doesn't work. How about 54 divided by 9? That works. Okay, so I hope you see what my mistake was here. So my mistake here, and I leave these mistakes in the video because I want you to see how they come up. The mistake here that we see is that I am in my head trying to figure out what divides into 54. And I'm like, oh, 27 divides in. It's 27 divided by 2. So I jump to 27. But 27 is not a perfect square, right? The perfect squares are 49, 36, 25, 16, 9, 4, and 1. So I get 9 to work. Okay, so because I got 9 to work, I'm going to break this radical 54 up into radical 9 and radical 6. Remember, the perfect square must come first. The final step here is to simplify, and I can simplify that radical 9 into a 3, but I leave the radical 6. So my final answer here is 3 radical 6. Let's check that, see if we get the right answer. So I'm going to type 3 radical 6, submit answer. I can see that green check mark there behind my calculator. I got it right, and I'm good to go. So the next assignment that you're going to get from me, okay, is going to be mixed. It's going to have 5 questions that are just practice simplifying perfect squares, 5 questions that are practice with the Pythagorean theorem simplifying these perfect squares. Because the further we get in our discussion of right triangle trigonometry in this class, we're going to need to be able to simplify radicals. Okay, we're going to need to be able to simplify those. So with that being said, that's going to be our assignment for the rest of the week. On Monday, we'll see something new. Okay, hope that works for you. Hope please reach out with any questions, and I hope that you and your families are doing well.